All right, this is Chapter 1, Lesson 5. This lesson is all about graphing proportional relationships. First, I want to review a little bit of what graphs look like. So, on this page 16, we have an actual physical graph, and you see a lot of different items and blanks over here. So we're just going to go through them and make sure we remember exactly what each one is. So the first thing I'm going to do is I'm going to start over here in this left-hand side with the bottommost blank. So in this blank down here, this is pointing to what is called our x-axis. So that's our x-axis. I'm going to go ahead and highlight our x-axis in green. The next blank is pointing to the very center where the axes meet. That's called our origin. The third blank points to what is called the y-axis. And I'm going to highlight the y-axis in pink. You do not have to highlight the x and the y-axis, but if it helps you, it might be a little bit more helpful so you've got a little bit more color on the page. Now remember, these are doodle notes. You can kind of draw in color and however it works for you. Okay. Now on this blank up here, it says the blank corresponds to the number on the x-axis. It's pointing to the 1. So the x-coordinate corresponds to the number on the x-axis. So this tells me how far over, remember because the x is green. I want to make sure it's green. The x is green, so it tells me how far over on the x-axis I need to go. And then over here it says the blank corresponds to the number on the y-axis. Well, if this one coordinated to the x-coordinate, this one's going to be the y-coordinate. I'm sorry, the boxes are really small. Okay. So that's going to tell me how far up and down I need to go. Now on this box over here, it's pointing towards the 1, which is the x-coordinate. And then the second one is pointing towards the whole, which is the ordered pair. Okay, so the ordered pair consists of 1, 2. That's actually the pair. Okay, and then the last one is pointing to the 2, which is our y-coordinate. Okay. You can also see that each of the quadrants is labeled. So I have quadrant 1, where both the x and the y are positive. Quadrant 2, where the x is negative and the y is positive. Quadrant 3, where both x and y are negative. And quadrant 4, where the x is positive and the y is negative. Now at the bottom, it says maps have grids to locate cities. The blank blank is a type of grid that is formed when 2 number lines intersect at their 0 points. So in those first 2 blanks, you're going to write coordinate plane. And this isn't a plane like you fly in, but it's actually a specifically designed math term. So maps have grids to locate cities. The coordinate plane is a type of grid that is formed when 2 number lines intersect at their 0 points. The number lines separate the coordinate plane into 4 regions called blank, which is quadrants. And finally, and blank blank is a pair of numbers such as 1, 2 used to locate or graph points on the coordinate plane. In those 2 blanks, you're going to write ordered pair. So that takes care of this page. We've gone over graphing, remember when we're given 2 points in ordered pair, we go over either positive or negative and then up or down. So always X then Y. You have to walk before you can fly. All right, on the next page, so on page 17, we have the second portion of our doodle notes. Okay, it says over here in the little cloud, another way to determine whether two quantities are blank, you're going to write proportional, is to graph the quantities on the coordinate plane. If the graph of the two quantities is a straight line through the origin, then the two quantities are proportional. So basically, in order to be proportional, it has to be a straight line that goes through the point 0, 0. If it doesn't go through the point 0, 0, then it is not proportional. So it's non-proportional if it does not go through 0, 0. Okay. So the example they give me talks about the slowest mammal on Earth. So the slowest mammal on Earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. Explain your reasoning. So first I'm going to make a table to find the number of feet walked for 0, 1, 2, 3, and 4 minutes. So obviously if the sloth there's no time wasted, the sloth hasn't gone anywhere, so the first point is 0, 0. So it already meets our first criteria of being a proportional relationship. At 1 minute, the sloth walks 6 feet. That's the speed that they originally gave us in the problem, 6 feet per minute. At 2 minutes, the sloth has moved to 12 feet. Because it's moving 6 feet per minute, it's moving at a constant rate, so it never changes. At 3 minutes, it's moved 18 feet, and at 4 minutes, it's moved 24 feet. So now that I have that, I can look and see that yes, 6 divided by 1 gives me 6, 12 divided by 2 gives me 6, 18 divided by 3 gives me 6, and 24 divided by 4 gives me 6. So I can see that these all equal 6, which means that's a proportional relationship. But I want to double check and make sure because I want to do this by graphing. So on step 2, it says graph the ordered pairs, time, comma, distance, on the coordinate plane. Then connect the ordered pairs. So I've gone ahead and graphed them. So I start at 0, 0. Then I have 1, 6, 2, 12, 3, 18, and 4 is off the chart so you can't actually see it. The line passes through the origin and is a straight line, so the number of feet traveled is proportional to the number of minutes. So I've given you 2 problems to try on your own. So go ahead and pause the video, and then once you've tried them, we'll resume back and talk about how you got the answers. All right, so now that you've tried the problems on your own, we're going to look at the answers. So the first one says, James earns $5 an hour babysitting. Determine whether the amount of money James earns babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane and explaining your reasoning. So it's going to be a little tight, so I'm going to actually work a little bit over in the margin. So the first thing I'm going to do is create a chart. I'm going to go ahead and create a T-chart. Okay. So the first one is going to tell me the time, and the second one's going to tell me the money he makes. Well, if James doesn't work at all, how much money does he make? So if he works 0 hours, he earns no money, so 0, 0, 0. So that tells me my first point is going to be 0, 0. So that's already meeting my first criteria of being a proportional relationship. After 1 hour, he earned $5. So I go over to 1, up to 5. Graph my point. At 2 hours, he earned $10 because he's earning $5 per hour. So at 2, I go up to 10. Now I can take a ruler or straight edge, line up the dots, and connect them. Notice that I get a straight line, and it goes through 0, 0. This means that my relationship is proportional. Don't forget to explain your reasoning, because that's what it asks you to do in the problem. So James earns a constant rate of money, so it is proportional. You could also include explanations as to the line being straight and it passing through the point 0, 0, or the origin. Now, the last problem I have says the table shows the number of calories an athlete burned per minute of exercise. Determine whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane. Explain your reasoning. They've already done the table for me, so I'm going to go ahead and graph my points. So my first point is 0, 0. My second point is 1, 4. So I go over to 1 and up to 4. Then it's 2, 8. And then it's 3, 13, which is actually off the chart. But I can look at this and go 4 divided by 1 is 4, 8 divided by 2 is 4, and 13 divided by 3 is not 4. This tells me it's a non-proportional relationship, which means when I graph this, all my points won't match and it won't be considered a straight line. Notice that this point is a little bit above where my line actually ends up. This also shows me that it wouldn't be a straight line because this would have to go up even higher in order to actually be on the line, which means that this is not going to be straight. So this is non-proportional. Because the graph is not a straight line. Even though it does go through the origin, the line is not going to be fully straight.